Have you ever wondered why we have never measured the one-way speed of light? A fascinating question, isn't it? Let's unravel this cosmic mystery together. Once upon a time, the speed of light was considered infinite. That's right, it was thought that light traveled instantaneously from point A to point B. Then, along came Danish astronomer Ole Romer, who turned this belief on its head. Observing the eclipses of Moon Io by Jupiter, Romer concluded that light takes time to propagate. In today's world, we generally accept that light does indeed have a finite speed. However, the common practice is to measure this speed in two directions. Imagine a ping-pong ball bouncing back and forth between two paddles. That's essentially how we measure the speed of light, from point A to point B, then back to point A. You may ask, why not measure it in one direction? Well, there lies the challenge. So, what exactly makes measuring the one-way speed of light so tricky? Well, the challenge lies in the synchronization of clocks for a one-way measurement. Let's break it down. Imagine you have two clocks, one at the point where light starts and the other where it ends. To measure the one-way speed, you'd start the first clock when the light leaves and stop the second when the light arrives. Sounds pretty straightforward, right? But here's the catch. In the realm of physics, clocks don't just tick away without being influenced by their surroundings. According to Einstein's theory of special relativity, time can warp and weft based on the speed and gravitational field of the observer. This means that synchronizing two clocks, especially over large distances, becomes a monumental task. Even if we could perfectly synchronize our clocks, they may not stay synchronized due to these relativistic effects. It's like trying to play a game of catch with a friend on a moving train. The train's motion affects how the ball travels, making it an entirely different game. So measuring the one-way speed of light isn't just about timing light's journey from point A to point B. It's about grappling with the fundamental nature of time and space themselves. It's not as simple as setting a stopwatch, is it? But didn't Einstein have something to say about this? You're absolutely right. The great physicist Albert Einstein indeed acknowledged the assumption that light travels at the same speed in all directions. This assumption actually played a pivotal role in his groundbreaking theory of relativity. Einstein's theory of relativity is a masterpiece of scientific thinking, and the assumption of the constant speed of light is its cornerstone. It's a bit like the foundation of a house. If you take it away, the whole thing could collapse. Einstein suggested that light speed is the same in all directions, regardless of the observer's motion or the light source. This assumption allowed him to develop his special theory of relativity, fundamentally altering our understanding of time, space, and the universe. However, it's important to remember that this is an assumption. Despite its wide acceptance and the numerous predictions it has helped confirm, it hasn't been definitively proven. But, as they say, the proof is in the pudding. And Einstein's pudding has stood the test of time with its predictive power and consistency with experimental data. So if it's good enough for Einstein, it should be good enough for us, right? But wait, isn't science all about questioning assumptions and seeking answers? Of course it is. But sometimes, despite the most valiant efforts, some mysteries remain unsolved. The one-way speed of light is one such enigma. Scientists, through the years, have strived to measure it, but to no avail. The challenges, as we've discussed, are not just about technology. They're deeply rooted in the principles of physics itself. Synchronizing clocks, for instance, is impacted by the effects of special relativity, making the measurement of one-way speed of light incredibly tricky. This has led to a rather curious situation. In the absence of a definitive solution, the scientific community has had to accept an assumption. They've had to concede that light travels at the same speed in all directions. But don't be disheartened. This unresolved mystery is not a defeat. Rather, it's a testament to the endless wonders of our universe, a reminder that there's always more to discover, always more to understand. For now, the one-way speed of light remains a fascinating mystery, a testament to the endless wonders of our universe.